Yes, good afternoon, students. Let us start the session today. I think yesterday I have discussed about a discrete time Fourier transform and a discrete Fourier transform, formulas and how to solve some problems, all those things. So before entering into the previous problems of those topics, just whether it is needed or not needed, FFT concept, briefly introduction I'll give to you. Fast Fourier transform. Actually, fast Fourier transform, it reduces the number of complex multiplications required to perform DFT from n square to n by 2 log n by 2. Now this FFT is executed means by using butterfly diagrams like this. There are two butterfly diagrams. One is decimation in time. Second one, decimation in frequency. So if you have 2 points A and B, here this should be executed as here arrow mark from B. Here this W suffix capital N to the power of K is called twiddle factor. In terms of this twiddle factor, the outputs of butterfly, these two, it is A plus Wn to the power of K B, whereas lower one A minus Wn to the power of K B. In a similar way, decimation in frequency diagram will be like this. Here, from A downwards the arrow mark, and this should be A plus B for output, and lower output it will be A minus B twiddle factor. You must by heart this. And furthermore, in decimation in time, input sequence is in bit reversal order. Whereas in decimation frequency, output sequence obtained in bit reversal order. This point should be remembered. And same notation follows here also. X of k you will get as x complex conjugate of n minus k, where n is the length of the sequence, whether 4-point or 8-point, whatever. Yesterday in the previous session I have given. Some more points about this FFT is, I think all of you noted. We go to the next page. Without erasing, I'm going to the next page. Yes, some note points. First point is the number of stages is log n base 2. That is for 8-point, if we have log 2 to the power of 3 to, that is equal to 3 stages for 8-point sequence. Second one, each stage consists of n by 2 butterflies. Third point, number of complex multiplications is n by 2 log n base 2. Fourth one, if audio is in mute condition, please let me know. Unlike yesterday. Fine. Number of complex additions just write like add additions. These multiplications here like this. So number of complex additions is n log n base 2. This is what some points to be remembered about FFT. Now let us see some previous problems based on these topics. I hope all of you noted this. Let's go to the next page. Let us GATE 2005 problem. Let x of n is given as 1 by 2 to the power of n u of n. And y of n is given as x square of n. And y of e to the power of j omega is the Fourier transform of y of n, then y of e to the power of j0 is so what is y of n here? X square of n. X of n is given. So x square of n you take it and then apply the z transform. And z replace with e power j. Or directly y of e to the j omega formula also you can apply. So let's see the solution for this. Here y of n is x square of n, that is x of n multiplied by x of n, that is 1 by 2 whole power n u of n multiplied by 1 by 2 whole power n u of n. You know that u of n multiplied by u of n equal to u of n. 1 into 1, 1, right hand side. So that it is 1 by 2 whole power n, 1 by 2 whole power n u of n. So 1 by 2, 1 by 2, 1 by 2 whole square, that is 1 by 4 to the power of n u of n. So a function y of n is given as 1 by 4 whole power n u of n. Is it? Then what is the question asked? It is y of e to the power of j0. From this, if you know y of z is what? Z upon z minus a. This. That implies to z replacing with e to the power of j omega is what? E to the power of j omega by e to the power of j omega minus 1 by. And for discrete time Fourier transform, we got this expression means we ask e to the power of j0. So y of e to the power of j0 means y of e to the power of j omega value with omega tending to 0. That means e power j omega divided by e power j omega minus 1 by 4 with omega tending to 0. That is 1 by 1 minus 1 by 4. So nothing but 4 by 3. Option D is the right one. Next question. I think I'll have noted. I'm going to the next page. GATE 2009 question. The 4-point DFT of a discrete time sequence one, 0, 2, 3 is the options are given like this. 0 minus 2 plus j2 2 minus 2 minus J2. Option B. 2 plus J2, 6. 2 minus J2. Option C. 6. 1 minus J3. 2. 1 plus J3. B. 6 minus 1 plus J3. 0 minus 1 minus J3. So observe the options. So finding the DFT of a sequence is very time taking, we know. It is very time taking to find all the DFT, each element. But we know one thing here. X of k is equal to x complex conjugate of n minus k for 4 point. X of 1 is equal to x complex conjugate of 3. Right. So x of 1 this one, x of 3 this one. Are they both complex conjugate? Verify. Yes. This one, complex conjugate. This one, complex conjugate. This one, complex conjugate. That means we need to verify 1 and 3 elements for this. And only we have to verify this first element and third element is different. First element and third element is different. In case logically, if you think first element here 0, first element here 2, first element here 6, here also 6. Definitely 2 equal means we have to calculate third also. So if you calculate first element, if you get to both are equal, once again you have to calculate the third element to verify. So logically, if I think if we calculate third element, then it will be clear. So assuming that, let us find the third element first. What is third element? X of 2. Here the point is x of 0, x of 1, x of 2, x of 3. These 3 elements are given. So if I find x of 2, so there is a chance to get that answer. What is x of 2 formula here? Limit n tending to 0 to third point, that means up to 3. N value 4 now, n minus 1, 3. X of n e to the power of minus j 2 pi by n k n. This is the formula. So n here k value 2 taken and capital N value 4.6 4 given. So further what we can modify this one, n value 0 to 3 x of n e to the power of minus j 2 pi by 4, k value also fixed to n. So this 4 2 cancels. So what is final? N value 0 to 3 x of n e to the power of minus j pi n. E power minus j pi n value how much? Cos pi n minus j pi n. Cos pi is minus 1, sin pi always 0. So that this is minus 1. Substitute the values. So that it is x of 0 into minus 1 plus x of 1 into minus 1, x of 2 into minus 1, x of 3 into minus 1. Substitute the values. X of 0 is 1 minus 1 plus x of 1 is 0. No problem. Next, x of 2, it is plus 2. Plus 2 into minus 1. Plus x of 3, it is 3. It is into minus 1. So how much you are getting? Minus 1, minus 2, minus 3. We are getting minus 6. So minus 6 is somewhere I have done mistake because minus 6 is not there. third element. Just let me verify once again. In value part. Yes. Here, -1 I have taken for all m. That means n value is taking from 0, 1, 1, 2, 3. Respect of this, I have taken all m. Yeah, there is a mistake. So these points I have to modify. Fine. Here n value 0 means e power 0, 1. That means here 1. N value 2 means e power minus z 2 pi. So cos 2 pi will be +1. Next, n value 2. N value means cos 2 pi. Cos pi value -100. N value 2 means cos 2 pi minus j sin 2 pi. Cos 2 pi is +1. Next, n value 3. Cos 3 pi is -1. Cos odd pi is -1. Cos even pi is +1. In that case, this is 1 into 1 plus this is 0. This is 2 into 1 and this is 3 into -1. -3. So we got 1 plus 2 minus 3. So that 3 minus 3, 0. We got 0 for this third element. X of 2 is equal to 0. How many elements with x of 2 is equal to 0 out of all 4 options? Only one element we got 0 for x of 2. Then directly we can answer this one without calculating other elements. So for this again, this formula helps us. Remember this formula, very, very important to answer this kind of questions. It saves a lot of time for us. So option D is the right one. Fine. One more question. GATE 2010 question. 4-point DFT. 4-point DFT of a real discrete time signal x of n of length 4 is given by x of k for n value 0, 1, 2, 3 and k value 0, 1, 2, 3. It is given that x of 0 is equal to 5, x of 1 is equal to 1 plus j, x of 2 is equal to 0.5. Then capital X of 3 and small x of 0 is R. 1 minus j 1.8 b 1 minus j 1.5 c 1 plus j 1.8 d 0.1 minus j 0.1 1.5. Identify the right option here. The 4-point DFT is given. 4 length. X of k values 3 given. X of 3 not given. Fourth one not given. We have to find first fourth. And then from all these, we have to calculate time domain initial value. X of 0. You know the DFT and inverse DFT formulas I have given in the previous session. So anyway, first to find X of 3, we have one logic. What is the logic for X of 3? Here X of 3 should be X complex conjugate of 1. So this is 1 plus j X of 1. This complex conjugate, that is 1 minus j. That is fine. And X of 0. For X of 0, what is the formula? 1 by n value 0 to n minus 1, X of k e to the power of plus j 2 pi n k small. This is the formula for X of 0. Generally for X of n, this is the formula. We take this X of n. Then this is n value 0 if you take, you get the X of 0 value. This is for X of n. You take n value 0. What is X of 0? 1 by n. N value 0 to n minus 1. X of k e to the power of, this is 0 means 1. Total will be 1. So you need to calculate just 1 by n value 4, sum of all the values. That is 5 plus 1 plus j 0.5 plus 1 minus j. Sum of all values divided by 4. So any cancellations here? 1 by 4, 5. Here jj cancels. This is 2 plus 0.5. So 7.5 by 4. Or else you can say 4 1 just 35. 8 just and so on. So X of 0 is 1.8 and X of 3 is 1 minus j. 1 minus j 1.8 is the right option. So that is the right option is option A. One more question. This is GATE 2011 question. The first 6 points of the 8-point DFT of a real valued sequence or 5 1 minus J3, 0, 3 minus J4, 0, 3 plus J4. Then the last 2 points. Then the last 2 points. Last 2 points of the DFT are respectively to try it out. Please resolve this. Which one? So 6 points he has given. Last 2 points he asked. How can you proceed? We have for 8 point, I have given the relations. The relations I have given like this. X of 1 is x complex conjugate of 7. X of 2, x complex conjugate of 6. X of 3, x complex conjugate of 5. Or reverse. What we want here, this is x of 0, x of 1, x of 2, x of 3, x of 4, x of 5 we have. We have in our hand up to x of 5. Then x of 7 we want. That is x complex conjugate of 1. What is x of 1? 1 minus J3. 1 minus J3 complex conjugate is 1 plus J3. Similarly, x of 6, it is a complex conjugate of x of 2. What is x of 2? 0. So obviously this is also 0. So 0, 1 plus J3 is the required last 2 points. 0, 1 plus J3. So what is the right option? Option B. Next question. I think all of you noted. Going to the next question. Fine. 2007 question. Leo Thomas. Mute yourself. Fine. 2007 question. It is a 5-point sequence x of n. A 5-point sequence x of n is given as x of minus 3 equal to 1 and x of minus 2 is equal to 1. X of minus 1 is 0. X of 0 is equal to 5. X of 1 is equal to 1. Let x of e to the power of j omega denoted by DTFT of x of n then the value of integral minus pi to pi x of e to the power of j omega d omega is. What is the value of that expression? Is 5 or 10 pi or 16 pi or 5 plus j 10 pi. What is the answer? Let us see. What we need to find the given integral. Where do we see the integral? Just look up. This integral, where do we see? This integral, if you take x of n, inverse DTFT. Whenever integral is a continuous function of spectrum is nothing but DTFT, not DFT. DFT is both discrete, time domain and frequency domain. Only continuous is DTFT. So DTFT, inverse discrete Fourier transform formula, we have to remember that is x of n is equal to 1 by 2 pi integral minus pi to pi capital X of e to the power of j omega multiplied by e to the power of, since this is inverse, plus sign d omega. This is the formula we have. But we have only x of e to the power of j omega. There is no exponential multiplied. So we can make it this term equal to 1. How can we make it that 1 equal to 1 means by taking n value 0. So that x of 0 both sides, n value 0 if we take both sides, it will become 1 by 2 pi integral minus pi to pi x of e to the power of j omega. This term whole will become 1, e power 0 1 d omega. Now the required expression is nothing but if we take this 2 pi this side, we will get integral minus pi to pi x of e to the power of j omega d omega should be equal to 2 pi x of 0. This is 2 pi x of 0. Then what is x of 0? We know x of 0 is given in the question 5. That means 2 pi multiplied by 5 means 10 pi. That is the equation required. The value of that integral he asked. We converted into the required and known parameters. That is 10 pi. So right option is B. Next. GATE 2016 question. I think all of you noted them. Consider x of n is equal to 6 del of n plus 2 plus 3 del of n plus 1 plus 8 del of n plus 7 del of n minus 1 plus 4 del of n minus 2. This is the given sequence x of n. If x of e to the power of j omega is DTFT of x of n, then one by pi integral minus pi to pi x of e to the power of j omega sine square 2 omega d omega is. What is that function? Expression equal to x of n given. X of n given here. So what about that function? Just to think of it. So the given expression it is one by pi integral minus pi to pi x of e power j omega. This is sine square theta. We can write it as 1 minus cos 2 theta by 2, right? This is 1 minus cos 2 theta by 2. This is the expression. Further, let us manipulate this one as first term x of e to the power of j omega and 1 by 2 is there. 1 by 2, let us write outside. Minus 1 by 2 pi minus pi to pi cos 4 omega x of e to the power of j omega d omega. So from minus pi to pi, any cos function, we take positive cycle and negative cycle, both will have same area, addition will become 0. So second term will be 0. What about the first term? First term, if you recall, this is nothing but x of 0 expression. Do you recall? Just a minute. X of 0. Observe here x of 0. Just a minute. So x of 0 is what happens? 1 by n, sigma n is equal to 0 to n minus 1, x of k. X of 0 expression is 1 by n, sigma n value 0 to n minus 1, x of n. Or x of k, or x of e to the power j omega. Discrete transform. This is x of 0 is in DTFT formula is 1 by Actually, here e to the power of j omega n is there. N value, since it is 0, we can take it as 1. This is what the expression. So this expression is nothing but this is x of 0. So from the given expression, x of 0 is what we have to identify. X of n we have. There x of 0 is what? Where impulse function is 0, that del of n is only one thing. So from this term, x of 0 will be 8. So the answer for this question is 8. One more question. And last question from this. This is GATE 2005 question. This is a given signal x of n. A sequence x of n has non-zero values as shown in the figure. Then find Fourier transform of y of 2n given y of n is equal to x of n by 2 minus 1 when n value even. Y of n value given, but y of 2n Fourier transform asked for this signal. So the options are given like this. E to the power of minus j omega cos 4 omega plus 2 cos omega 2 cos 2 omega plus 2 b cos 2 omega plus 2 cos omega plus 2 c e power minus j omega cos 2 omega plus cos 2 cos omega plus 2 d e power minus j 2 omega cos 2 omega plus 2 cos omega plus 2. Then find the Fourier transform of y of 2n. So what is y of n? It is given that x of n by 2 minus 1. That implies to y of 2n will be x of n replaced with 2n. That means x of n minus 1. Then y of 2n graph will be x of n graph shifted by 1. So this should be shifting here, this should be shifting, this should be shifting, this should be shifting by 1 element. So that the graph starts at minus 1. Here it is off, here it is 1, and At 1 it is 2. At 2 it is 1. At 3 is 1 by 2. Simply discrete and Fourier transform of this function. It is nothing but E of 2n. In terms of impulse function, you can write it as 1 by 2 del of n plus 1 plus del of n plus 2 del of n minus 1 plus del of n minus 2 plus 1 by 2 del of n minus 3. This is y of 2n in terms of impulse functions. You can just apply the Fourier transform on both sides. So y of 2n is nothing but x of n minus 1. We want this Fourier transform. Therefore, it is 1 by 2 del of n1 shifting. That means e to the power of j omega plus 1 plus 2 e to the power of minus j omega plus e to the power of minus 2j omega plus 1 by 2 e to the power of minus j3 omega. Right. To simplify this one, what can we do means just 1 is there, or are not in a required format to convert into cos functions. So we can do one thing here. So let's take e to the power of minus j omega common from these terms. Then what happens? This is first term will become 1 by 2 e to the power of, this is j2 omega. So that 2 omega minus omega plus omega, it matches. 1 is there, that means e to the power of plus j omega should be there. So that e to the power of plus j omega multiplied by e to the power of minus j omega will become 1. Like that, remaining terms. This is minus j omega common means 2 remains. Next, this is e to the power of minus j omega. Plus last one e to the power of minus j2 omega. So that if you observe, this is 2 omega, this is 2 omega. We can combine into exponential. And this is 1 omega, this is 1 omega. We can combine into exponentials. Right. So that e power minus j omega and this 2 omega combination, if we take cos 2 omega, it will be, and minus j omega plus j omega, if we combine 2 cos omega, only one term remaining 2. Which option matches you can verify. E power minus j omega cos 2 omega 2 cos omega plus 2 means, so this is option C, right one. I think all of you noted. Now one more small topic. Just I need to give introduction or few details of the topic. It is phase and group delay. Phase and group delay. You all of you noted this? Fine. The small heading, phase and group delay. Here, a particular system, if you consider, if you transmit some input signal, the received signal, output signal, generally it is having some phase shift with respect to input. Simply we can call it as phase lagging. This is of some carrier frequency FC. Here the phase shift will be some theta of FC. Here what is this phase delay means? The time how much it takes to lag is total phase shift. The phase delay is represented like this. Tau, it is take suffix P for phase. Tau stands for delay. Is minus of theta of FC divided by 2 pi FC. Or else in terms of omega if you want. Minus theta of omega by omega. Second, root delay means this is minus 1 by 2 pi d theta of FC by df. Or in terms of omega if you want, minus d theta of omega by d omega. Okay. Actually, this is first one is called carrier delay. This is called true delay actually. Actual true delay. Or we can also call it as root delay or envelope delay. It's called envelope delay. This is called as true signal delay. And here, just I'll give you one systematic representation for this concept. Hope all of you noted. Fine. If it is transmitter side, a modulated signal is there. These students are most familiar about this concept. The message signal M of t, carrier signal C of t. Combined to signal, modulated signal, S of t is equal to, let us take M of t, C of t. That means this is a DSB modulated signal, right? C of t generally a high frequency carrier signal, we know that we can write like this also. This DSB signal is transmitted through the system or channel. Based on the channel characteristics, the delay will be there. Then the receiver side, this received signal Y of t is having some constant M of t minus tau g cos two pi fc into t minus tau p. So observe the tau p and tau g positions. Here message, this is the group delay. This is carrier, this is the phase delay. You know the modulated signal form. If it is low frequency message signal, if it is high frequency carrier signal, then the carrier signal will be taking the form of message signal. So where the envelope meaning is the track of peak points of the wave. What the dotted line is nothing but carrier signal. But originally carrier signal amplitude is constant. After modulation, the constant takes the form of message signal. Whatever the dashed line, this is message signal. Whatever the thick line, that is carrier signal. Okay. The delay in the carrier signal is taken as phase delay. The delay in the total envelope. See, envelope here, this is called envelope. Message signal shape is nothing but envelope. Fine. I think all of you noted. Now I'll discuss one more point about this phase and group delay. Just I'm removing this. For example, consider a system distortionless transmission system. So, for example, a system, if you transmit signal x of t, you will receive some signal y of t. If it is in the form of x of t minus t naught, then we say that distortionless system. Means what? Amplitude can be scaled. Time can be shifted with respect to the input signal x of t. Those two are not considered as a distortion. If you transmit this signal, if you get this signal here, that is not transmission error. Distortion is not considered. If you transmit this signal with the 5 amplitude, you receive at 10 amplitude, that is also not a distortion. Or if you receive the signal like this, distortion. It's a distorted received signal. So until the original wave shape of the signal which is transmitted through the system is not disturbed, that is considered as distortionless system. The amplitude changing position shifting is not at all considered as distortion in the system. Right? Provided the system is a distortion in the system, we have y of t is equal to k into x of t minus t naught. I'm applying Fourier transform so that y of omega is equal to k into, because of shifting, exponential multiplication, and this is nothing but magnitude of received signal is what? K. Phase of received signal is what? Minus omega t naught. What now? This is magnitude. Here, apart from the remaining phase. If you plot amplitude and magnitude characteristics of system function, it is what? Y of omega by x of omega is nothing but h of omega. System function is k into e to the power of minus j omega t naught. So what is magnitude of system function is k. What is phase of system function is minus omega t naught. So system function magnitude response, if we say, is k, constant. Whereas phase of system function, we take minus omega t naught. Omega value if you take on x-axis, minus omega. So that phase response will be like this. What is the slope? Means minus t naught slope. Is it? Function is minus omega t naught, phase function. This is what? Theta of omega, phase function. Then for this function, if you know the phase, what is the phase delay and the group delay? Let us determine here in the left hand side of the page. I am doing. Here phase delay I want. Phase delay formula, theta of omega by omega minus group delay formula minus d theta of omega by omega. So this is minus theta of omega by omega. Theta of omega is what? Minus omega t naught divided by omega. So that minus minus cancel, omega omega cancels. We are having t naught. Consider the group delay. Minus d theta of omega minus omega t naught d by d omega. What happens? T naught constant. Here minus minus plus. T naught outside. D by d omega of omega is 1. So T naught. So for distortionless transmission system. So for distortionless transmission system, phase delay should be equal to group delay. That's what the conclusion. Next, let us start Laplace transforms. Hope all of you noted. Laplace transform, let us see. First, a few points about the Laplace transform. Laplace transform expresses signals as linear combination of combinations of complex exponentials which are eigenfunctions of differential equations which describe continuous time LTI systems. Next point. The major role of Laplace transform is the transient and stability analysis of causal LTI systems. And many design techniques in circuits filters and control systems have been developed in Laplace transform. And Fourier transform not defined for unstable systems, but Laplace transform can do. Some signals not Fourier transformable also can be Laplace transformable. Some signals which are not Fourier transformable can also be Laplace transformable. RAM function don't have Fourier transform, but we have Laplace. And you can say there is no ROC concept in Fourier transform, but we have ROC concept in Laplace transform. I think all of you noted. Point 6 point, sir. 5th point. So 6th point. No ROC in Fourier transform, but ROC in Laplace transform. No initial value theorem and final value theorem in Fourier transform, but in Laplace transform. Duality property exists in Fourier transform, but not in Laplace transform. Signum function Fourier transform exists, but Laplace transform does not exist. Let us see the Laplace transform formula. I think all of you noted down. Fine. The Laplace transform converts signal from time domain to S domain, where S is equal to sigma plus j omega. Sigma is the real part, omega is imaginary part. Okay. So x of t Laplace transform, x of s is defined as minus into plus infinity, x of t e to the power of minus st dt. If s is equal to sigma plus j omega minus into plus infinity, x of t e to the power of minus of sigma plus j omega t, that is equal to minus into plus infinity, x of t e to the power of minus sigma t e to the power of minus j omega t. We take this one as function. So that is nothing but Fourier transform of x of t e to the power of minus sigma t. That is the relation between Fourier transform versus Laplace transform. Here, the range of values of sigma over which x of s converges. X of s converges is called region of convergence of Laplace transform. I think all of you noted, Amma. Let us go to the next page. Fine. First, let us see the properties of ROC, and then we can go to the properties. Properties of ROC. The first property is ROC is a connected region in S-plane. ROC is a connected region in S-plane. Second, ROC should not contain any pole. Third one, ROC consists of vertical strips. That are parallel to j omega axis. Next, if x of t is finite duration, if x of t is finite duration, then ROC is entire S-plane. Entire S-plane, except possibly S is equal to plus or minus omega infinity. Like del of n minus 1, 2, 3, del of n plus 2, 3, 4. This kind of signals. Later you can verify. 5. If x of t is a right-sided signal, then ROC is region in the S-plane right side of the rightmost pole. Similarly, if x of t is left-sided signal, then ROC is region in S-plane left side of the leftmost pole. Seven. If x of t is both sided signal, then ROC is bounded between two poles. The ROC is region in S plane bounded between two poles. It's not much difficult compared with the GATE transforms. Since Fourier transform, GATE transforms already we have completed. Laplace transform is not at all a difficult task for us. Directly we can go. No need to worry much. Now I will give the properties of Laplace transforms. Now we have seen the properties of ROC. Simultaneously, let us see the properties of Laplace transform and then we can go for directly solving the problems. Fine, all of you noted, I think. Just property statements are given. The linearity property A x1 of t plus B x2 of t Laplace transform. A x1 of s plus B x2 of s. Next, time shifting property. X of t minus t naught is there. One side shifting, other side exponential multiplication. So x of s e to the power of minus s t naught. If it is plus, that is plus. Time shifting always same signature. Whatever the transform it may be. So shifting in S domain. That is, if it is u to the power of s naught t, x of t means one side exponential multiplication, other side shifting. But here plus s naught is there, so you take minus s. Frequency shifting opposite sign, time shifting same sign. Next, time scaling. Time scaling is if x of at Laplace transform 1 by mod a x of s by a. Okay. Next, conjugation property. It says that if x of t is real complex signal, then x complex conjugate of t Laplace transform is X complex conjugate of s complex conjugate. We know that s is a complex variable. Fine. Convolution property. Convolution property says that x1 of t convolution in time domain with x2 of t, then the Laplace transform x1 of s, x2 of s. Just one domain convolution, other domain multiplication. Next, time reversal property. Time reversal property says that x of minus t Laplace transform will be capital X of minus s. Next, differentiation property. This is property number 7, 8th property. Differentiation time domain. Differentiation time domain property says that if time domain signal is derivated, what happened in the S domain? That is simply S into X of S. Of course, in Z transform minus Z comes. Here it won't minus. Next, differentiation in S domain property. That is, if it is T multiplied in time domain, then it is minus D by ds of X of S. Observe this, n into X of n in Z domain, minus Z will come. Here, no minus Z. And differentiation in time domain is not existing in Z domain, because Z domain discrete time signals we apply. So discrete time signals we cannot differentiate and integrate. Fine. 10th one. Integration in time domain. This is integral minus infinity to t x of tau d tau. Its Laplace transform is 1 by s x of s. And finally, initial and final value theorems. Finally, initial value and final value theorems. Initial value theorem says that here limit x tends to 0 x of 0, so x of t, what is nothing but x of 0 is limit s tends to infinity s into x of s, whereas this one limit t tending to t tending to infinity x of t, that is x of infinity is limit s tending to 0 s into x of s. Compared to Z transform, it is easy to remember here. both Sx of s is there. Both are s into x of s. Here final value means here initial value. Here initial value means here final value. Easy to remember. Expression is same. But rules, if we observe here, conditions for initial value theorem, same condition as GATE transform. Numerator polynomial order should not be greater than denominator polynomial order. Numerator polynomial order should not be greater than polynomial order of denominator. Order. Okay. Order n. Numerator should be less than or equal to numerator order per denominator. That is the condition. Final value theorem, if you see, condition, all poles should be left hand side. One pole can be on the imaginary axis, however, that will be cancelled with the Sx of s. Only one pole can be on imaginary axis. Most one pole can be on imaginary axis, so that s into x of s, ss cancels. Even if you have a pole on the imaginary axis, that will cancel. That doesn't affect. That's why all poles of s into x of s must be left hand side. Simple to remember. There, GATE transform, all poles should be within the unit circle. Here the reference point is imaginary axis, not the unit circle. So all poles left hand side of the imaginary axis is the condition in the Laplace transform. And one pole on the imaginary axis, no problem, because that is cancelled with s x of s expression. Be careful while applying initial and final value theorems. Now let us solve some problems in Laplace transforms. First problem. Find Laplace transform on ROC. If x of t is del of t, then Laplace transform minus infinity plus infinity del of t e power minus st dt. From the impulse function property, it is shifting property e power 0, that is 1. So ROC is, since there is no s to verify all values of s, it is 1 only, converges. So n-type is plane. Second, x of t, u of t, then x of s, minus infinity plus infinity, u of t e power minus st dt. So u of t value 1 over the limit 0 to infinity, remaining e power minus st dt, so that it is e power minus st divided by minus s with t value 0 to infinity. Now observe, minus 1 by s e to the power of minus s infinity minus e to the power of minus s 0. Observe the condition here. E to the power of minus infinity is 0, e to the power of plus infinity is infinity, e power 0 is 1, you know. So for the convergence, this term should not be infinity. Okay? This term should not be infinity. So s value, if it is negative, minus minus plus, e to the power of plus infinity will be infinity. So strictly it should not be negative. So that we should say that real part of s should be greater than 0. then only this will become positive. If it is positive, e to the power minus infinity will be 0. No problem. And this is e power 0 will be 1. Fine. So this term should be 0, this term should be 1. Under the condition, real part of s greater than 0. So that minus minus plus, which is 1 by s with the ROC. Real part of s is sigma. Sigma greater than 0 is the ROC. So u of t, Laplace transform 1 by s with ROC sigma greater than 0. Quicker. Next, u of minus t, let us. Let us find u of minus t. U of minus t is minus 0, this is 1. Then x of s is minus infinity to 0, this is 1, e power minus st dt. Then x of s simplification, e power minus st by minus s with t limits minus infinity to 0. So minus 1 by s e to the power of 0 minus e to the power of minus s, and limit is minus infinity. Now observe how to take the values of s. We need this one, not infinity. Infinity should not be there. When it will be infinity? Here, first of all, minus minus plus. So if s value plus infinity, then this term will become infinity. If s value negative, that means minus infinity, no problem. This will become 0. So we can decide for convergence, s value negative. So under the condition sigma less than 0, x of s, what happens? Minus 1 by s. This one, however, 1 minus sigma less than 0, negative. Here negative means e to the power of minus infinity 0. This term will be 0. So what is x of s? Minus 1 by s. What is that? U of minus t, Laplace transform minus 1 by s with ROC sigma less than 0. If I multiply with the minus sign both sides, which is 1 by s with the sigma less than 0. Amplitude multiplying with minus sign cannot affect the ROC. T, individual variable t, if we multiply with minus, ROC affects. So that if we recall, u of t Laplace transform also 1 by s, but ROC is sigma greater than 0. We make this as a table. Here, these two are ROC same. These two are Laplace transform same, but ROC different. And these two are ROC same, but Laplace transform different. So any two different signals cannot have both Laplace transform and ROC same simultaneously. Anyone should differ, otherwise inverse Laplace transforms we cannot find it. There should be some one-to-one relation to find inverse Laplace transform properly. Noted? Now ramp function. Ramp function. X of t is equal to t into u of t. Okay. Ramp function, just for observation, r of t, no Fourier transform. Then t into x of t property given here. Differentiation term. T into x of t, we have minus d by ds of x of s. Right? Here x of t is u of t. Right? So u of t, Laplace transform 1 by s. Right? U of t Laplace transform 1 by s. Now if I multiply this at t into u of t, that's it. What should I do? Minus d by ds of 1 by s shall I do? That means what? Minus 1 by s square. Minus minus plus. 1 by s square is the answer. For example, I am multiplying one more t here. That means minus d by ds of 1 by s square. That means minus 2 by s cube. Minus minus plus 2 by s cube. What is this? T square u of t. Laplace transform is 2 by s cube. One more t I am multiplying. T cube u of t. That means minus d by ds of 2 by s cube. So minus 3 numerator, that means minus minus plus 2 into 3 divided by s to the power of 4. So can I write this one as 1 factorial by s square? This one as 2 factorial by s cube. This one is 3 factorial by s to the power of 4. So that if I have t to the power of n, u of t, Laplace transform what? Here 3 is there, the 3 factorial. So here n is there, we should get n factorial. And here s to the 4, n plus 1, s to the power of n plus 1. So carefully note down. If we have t to the power of n, u of t, Laplace transform it is n factorial s to the power of n plus 1. From this, what is s to the power of n? Inverse Laplace transform. We are decreasing n value by 1 here. So here also we can decrease n minus 1 will be in the numerator. I will bring this one. This one we can bring this side. That means t to the power of n minus 1 u of t divided by n minus 1 factorial. If I need inverse Laplace transform, 1 by s to the power of n. Fine. Next, one more. I think I have noted down. If x of t is e power at u of t, Find Laplace transform and ROC. So x of s in this case what happens? Minus into plus infinity e power at e power minus st. This u of t is there of course. So u of t value can be replaced with 1 over the limit 0 to infinity. We can combine these two exponentials e to the power of a minus s t dt. Right. Now let us simplify this one. E to the power of a minus st divided by a minus s with the t value 0 to infinity. 1 by a minus s e to the power of a minus s t. T means what here? Infinity. Minus e power 0. This however one not a problem. Now this one how should be? This is infinity. We should get minus infinity. So this one should be negative. A minus s should be less than 0. That means a should be greater than a. That means sigma should be greater than a. Then under that condition, what happens? This will be 0. So x of s will be 1 by a minus s. This will be 0. This will be 1. Or we can say 1 by s minus. So e to the power of at u of t Laplace transform is 1 by s minus a. What is ROC? Sigma greater than a. Why greater than symbol? This is right side sigma. Getting? One more question. Similarly, you can do here. Similarly, e to the power of minus at u of t. 1 by s plus a. Right side signal. Sigma greater than a. No much difference. Plus replace with minus. Nothing else. So e to the plus or minus at u of t I have found. Fine. One more question. This is, so we have e to the power of minus at u of t is 1 by s plus a. E to the power of at u of t is 1 by s minus a. So if x of t is cos omega t ut, we can write it as e to the power of j omega t ut by 2 plus 1 by 2 e to the power of minus j omega t ut. Then Laplace transform on both sides, what will you get? Here a value is just j omega. So this one can be written as 1 by s minus e to the power of j omega. Here plus is there means minus. Next term. Minus j omega is there, that way plus you will get. Let us simplify. This is s plus e to the power of j omega plus s minus e to the power of Second term is minus j omega. So this is j omega divided by s minus e to the power of j omega s plus e to the power of minus j. Any cancellations? No cancellations. So that 1 by 2, these two, I can write it as s to s plus these two, e power j omega minus e power minus j omega. If I write it, this one is minus. Minus, this can be written as 2j sin omega. And denominator it is omega minus j omega. I think I have taken directly e to the power of, it's j omega only I have to do it. Only j omega I have to. Then it is this is e to the power of 1 divided by s minus j omega plus j omega s plus j omega plus minus j omega j omega cancels. This is x minus j omega x plus j omega 2s by 2. 2 cancels, x divided by this is s square minus j omega whole square. J square minus 1 means minus minus plus omega. What I get means cos omega t u of t Laplace transform. I get s by s square plus omega. One thing, if we remember, ROC e power minus at u of t ROC what? Sigma greater than a. Sigma greater than a. That is plus or minus at. Then here sigma greater than j omega should be taken. Right. So on the S plane, j omega axis here. On the j omega axis, sigma value 0. Is it? So instead of writing sigma greater than j omega, the general representation of the ROC is, it is real part of S. It is a representation, that is nothing but sigma. So in terms of sigma, we have to represent the ROC. That's why instead of writing sigma greater than j omega, you can write sigma greater than 0. That means the same meaning. Don't worry. So whenever cos function, sin function is there, ROC write it as sigma greater than 0, or real part of x greater than 0. Don't write j omega in the ROC representation. That is not the conventional method. Anyhow, cos omega naught t u of t, answer is s by s square plus omega square. Similarly, sin omega t u of t, answer let us see. Fine. If x of t is sin omega t u of t, which is nothing but 1 by 2j e to the power of j omega t minus e to the power of minus j omega t. Let us find the Laplace transform on both sides. X of s is 1 by 2j outsides. This Laplace transform, we know that 1 by s minus j omega minus this Laplace transform 1 by s plus j omega. Further multiplication 1 by 2j s plus j omega minus s plus j omega divided by s minus j omega multiplied by s plus j omega. Any cancellations? This time ss gets cancelled. And 2j omega is there. So 2j omega by 2j means only omega remains. And in the denominator it is s square plus omega square. So we have sin omega t u of t Laplace transform omega by s square plus omega square, whereas cos omega t u of t Laplace transform s by omega square plus s square. Important weights. Next one. Next one I will give combination of exponentials. This is very important exercise. Directly you can use the formula to answer this, but finding ROC is an important task for this problem. Finding the ROC is an important task for this problem. Observe. First problem. If x of t 4 into u of e to the power of minus 2t u of t plus 8 e to the power of minus 3t. First problem. Second problem. X of t is 2 e to the power of 3t u of t plus 5 e to the power of 2t u of minus t. This is u of minus t, this is u of minus t. Both u of minus t. Next, third one. If x of t is equal to 3 e to the power of minus 2t u of t plus 5 e to the power of 3t u of minus t. Fourth, x of t is equal to e to the power of 2t u of t plus e to the power of minus 3t u of minus t. Find the Laplace transform and ROC of these signals. All are combination of two exponential signals. Just let us find directly by using formulas. Just I am telling x of s is here. This one directly I can take it as 4 into 1 by s plus 2. Second one, 8 into 1 by s plus 3. But what about ROC? This is both right side signals. Observe here, both right side signals, both left side signals, one right side, one left side signals, all combination here. So here, first the ROC is what happens to the first term. This is first ROC. This is sigma value greater than pole value minus 2. This is sigma value greater than pole value minus 3. So right side of the rightmost pole. So ROC is sigma greater than minus 3. Rightmost pole. Minus 2 is the rightmost pole, not jet transform. To consider only magnitude, not jet transform. Simply the S plane minus 2, minus 3. Right side of the rightmost pole. Fine. Come to the second problem. This is x of s. This is 1 by s minus 3. 2 is there. Plus 5 into. This is, since u of minus t is there, minus 1 in magnitude. It's also minus 1 by s minus 2. ROC what happens? Left hand side minus symbol. And this is the pole value. So that sigma less than symbol, pole value 3. Here also sigma less than symbol, pole value 3. Then less than 3, less than 2. Where could be the ROC? 2, 3. This is less than 2. This is less than 3. Common ROC is less than 2. So for this ROC is sigma less than 2. No problem. Third one. X of s 3 into 1 by s plus 2. ROC is right hand side. So greater than symbol. Pole value is 2. Pole value minus 2. And left hand side signal minus 5. 1 by s minus 3. So pole value is 3. So sigma value, left hand side signal less than symbol, pole value 3. So that we take minus 2 and plus 3 greater than minus 2, less than minus 3. Intersection region minus 2 to 3. Fourth signal, x of s. This is 1 by s minus 2 minus 1 by s plus 3. Here sigma value, right side signal. So greater than 2. This is left side signal, sigma less than minus 3. Observe 2 minus 3 greater than 2, less than minus 3. Where is the intersection region? No R1 intersection R2. So no ROs. Be careful with the fourth option. Individual signals are Laplace transformable with valid arrows. But when two signals are combined improperly, there may not exist the ROC and the Laplace transform. Next, one more question. The waveform is given like this. Find the Laplace transform of this signal. Right? I'll give you just 1 minute. So this question, we can represent in terms of the known signals. That is called waveform synthesis. For example, this is T U of T signal. But I have one more signal. So T minus 1 U of T minus 1. This signal shifted. Now I am subtracting these two signals. Then what I will get? This signal. Then we need only up to 2. So again, here U of T minus 2 signal. If I subtract this one, what I will get? This. Is it? So what can I write as the given signal x of t means? This is nothing but T U of T minus T minus 1 U of T minus 1 minus U of T minus 2. And we know that T U of T R of T Laplace transform 1 by s square and U of T Laplace transform 1 by s, and any shifting of the signal is its Laplace transform multiplied by e to the power of s t naught. We know these properties. Then x of s, what we can do? This is x of t. You need to find the Laplace transform of this signal. That is nothing but Laplace transform of this one. So t into u of t, that is 1 by s square. Next, t minus 1, u of t minus 1. That means by using shifting property. Minus of 1 by s square e to the power of minus s. U of t shifted by 2 units. U of t is 1 by s. Shifted by 2 units means u of minus 2s. Is it? Further, what we can do? We can change it to the required format. 1 by s square, we can take it common. Any other required format, whatever want, you can modify into the required format. But single step. If you can convert the waveform into the known waveforms by waveform synthesis, you can get it the Laplace transform very easily. This is also an important aspect. One more problem. Find the current I of t. Find the current I of t in a series RLC circuit as shown. When a 100 volt supply, when a 100 volts supply is switched on across terminals A dash at t is equal to 0. The circuit diagram is given like this. The circuit element values are given like that. When 100 volts supply is switched on across the terminals, you find the current. That is the question. Right. So, when 100 volts is applied to the circuit, after t is equal to 0, right? After t is equal to 0 means nothing but 100 multiplied by u of t, you can take in signals point of view. that is equal to, then resistor to voltage across resistor, supply voltage is nothing but resistor voltage plus inductor voltage plus capacitor voltage. So resistor voltage is how much? 2 into I of t. Inductor voltage how much? 1 into di of t by dt. Capacitor is 1 by capacitance integral of I of t dt. So apply Laplace transform on both sides. Then 100 by s is equal to 2 I of s plus derivative is s into I of s. Integration is 1 by 0.2 means it is 5 I can write. 5 I of s by s I can write it. From this, s if we multiply, then what I will get? 100 is equal to I of s, I am taking it common. And s multiplied this side means 2s plus s square plus 5. Or I of s is nothing but 100 divided by s square plus 2s plus 5. Further, how can we divide? Writing this I of s as 100 divided by s plus 1 whole square. If I write 4 remains. 4 I can write 2 square. Right. Then it can be written as s plus 1 whole square. 4 I am writing as 2 square. Then what is the inverse Laplace transform? This is omega by s square plus omega square form. Omega by s square plus omega square form, provided we have written 100 as 50 into 2. So 50 outside, omega by omega square plus s square. That will become sine. So that this is 50 sine 2t, sine omega t, na? Sine 2t, of t. It is shifting in s domain. That means multiplied with exponential e to the power of the frequency domain shifting means opposite sign to the so minus t. So this is the given signal in time domain I of t. Like that, you can proceed for the electrical circuit sequence. Now let us see some previous problems on Laplace transforms. We get 2010 problem. It is given f of t equal to inverse Laplace transform of 3s plus 1 divided by s cube plus 4s square plus k minus 3s if limit t tending to infinity f of t is equal to 1, then the value of k is what is the value of k? So here final value is that. So he has told that f of infinity is equal to 1. What is the final value theorem? We know. It extends to 0, h into x of s. Right. Limit extends to 0, s into f of s is equal to 1. F of s how much? Laplace transform, take this side. This is all f of s. So limit s tends to 0, f of s 3s plus 1, and then in this f of s can be taken common. So that s, if I take it common, s square plus 4s plus k minus 3 is equal to 1. Then ss gets cancelled. If I substitute s value 0, 1 divided by k minus 3 is equal to 1. If k minus 3 is equal to 1, k value 4. 4 is the right option. Next question. GATE 2015 question. Consider the function g of t is equal to e power minus t sin 2 pi t u of t, where u of t is a unit step function, then the area of g of t is area means this one. How to find the area of this one? G of t Laplace transform, if you consider g of s, that is minus into plus infinity g of t e power minus st dt. Fine. If you take s tending to 0, g of 0 is what? Minus into plus infinity g of t e power 0 is 1 dt. So this is what the area required. So if we know the g of s for this function, we can easily calculate g of 0 rate. So what is the g of s for the function g of t? That we want to know. What is the sin omega t u of t Laplace transform, we know that. What is an omega t u of t? It is omega by x square plus omega square. Then if it is multiplied with e to the power of minus t, so omega t u of t. One side multiplication, other side what happens? Omega plus 1 by s square into omega plus 1 whole square. Here omega how much? 2 pi. It's plus 1, not omega plus 1. Sorry. So omega by square plus omega square. Here s is shifting because of exponential multiplication. S value shifting. Then here omega value is 2 pi given in the problem. So e power minus t sin 2 pi t u of t. Laplace transform is 2 pi x plus 1 plus 2 pi square, 4 pi square. What is this? G of s. We want for the area g of 0. That means 2 pi divided by 1 plus 4 pi square. This is what the g of 0 value, which is the required area expression value. But if you simplify, you will get 0.155. This is the answer. One more question from 2015 paper. Very important. So analysis based question. Fine. Right on the GATE 2015, one more problem. Input x of t and output y of t of an LVI system are related by the differential equation y double dash of t minus y dash of t minus 6y of t is equal to x of t. If the system is neither causal nor stable, then the impulse response of the system is Options are given like this. One by 5 e to the power of 3t u of minus t plus 1 by 5 e to the power of minus 2t u of minus t b minus 1 by 5 e to the power of 3t u of minus t plus 1 by 5 e power minus 2t u of minus t. All are looks like same. Careful analysis mandatory here. 1 by 5 e to the power of 3t u of minus t minus 1 by 5 e to the power of minus 2t u of t. D is minus 1 by 5 e to the power of 3t u of minus t minus 1 by 5 e to the power of minus 2t u of t. Find answer correctly. Very, very important. System input output relation given to you. From that you can calculate the system function. From the system function, which signal you have to take right side, which signal you have to take left side, so that it satisfies the condition causality and stability. Causality means the left side signal should be non-causal because he has given neither causal. And stability point of view, LTI system stability means it should include imaginary axis j omega within the ROC. These are the conditions. Stability. J omega should include the ROC. Causality. Signal should be left side. Based on these two conditions analyze. Laplace transforms. First of all, from the condition, what is h of s? You can determine. H of s is what? Y of s by x of s. That is s square. Here s square will come here, s come here, minus 6 come. S square minus s minus 6. That will come into the denominator because x of s this side. So 1 by s square minus s minus 6. This one not a problem. We can easily do it the fractions, which is nothing but a by x minus 5 or minus 5 minus 1 if you take, you will get minus 1. That means minus 3 plus 2. So that what happens? Minus 3 s plus 2s minus s. But then it will be 1 by 5 minus 1 by 5 you will get. So h of s it is 1 by 5 1 by s minus 3 minus 1 by s plus 2. If you get this one, what is the inverse Laplace transform for h of n? of t. That's the impulse response of the system. Now observe the S-plane, one pole is at +3, other pole is at -2. So we have to include j omega axis, not stable is here. It should not include j omega axis. When it is possible. If both are right side, of course. If both are right side, it won't include. But what about other condition? If both are right side, then it cannot be neither causal, they will become causal. If both are left side, then what happens? Left side of the leftmost pole, it will be the ROC for both left side. Then what happens? J omega not including, so it will become unstable and non-causal. So for this, both left side case is matching. So both left side means it is 1/5 minus u of minus t with the power of 3t u of minus t minus plus e to the power of minus 2t u of minus t. Is it? So these two conditions are satisfied, which is non-causal and unstable. Simultaneously, these two conditions satisfied means both should be left-sided, then only it is satisfied. Which is the right option you can put up now. Minus plus minus plus. Option B. Okay. Option B satisfying this. Good tricky question. One more question. Write down one more question. GATE 2007 question. Good question. Write down 2007 question is like this. The function u of t plus 1 multiplied and convolution with r of t minus 2 is given by one by 2 t minus 1 u of t minus 1 next 1 by 2 t minus 1 whole square u of t minus 1 b c 1 by 2 t minus 1 u of t minus 2 none of the above. What is the right option for this? Time domain convolution is very difficult, so we have to go to the Laplace transform S domain and we should come back. Right. So u of t Laplace transform 1 by s we know, and r of t Laplace transform 1 by s square we know. So that u of t plus 1 time shifting multiplication with exponential. Here time shifting with same signature s. And r of t minus 2. So 1 by s square e to the power of minus 2s. So this side convolution means frequency domain multiplication. Right? U of t plus 1 convolution with r of t minus 2. Convolution of this two. 1 by s e to the power of s. So this is a convolution, this is a multiplication. 1 by s square e to the power of minus 2s. That is what 1 by s cube e to the power of minus s. I told you 1 by s to the power of n. Inverse Laplace transform t to the power of n minus 1 divided by n minus 1 factorial u of t. In that way, 1 by s cube inverse Laplace transform is t square u of t divided by n minus 1 factorial. That means 2 factorial. 2. And here e power minus s multiplied. So correspondingly here shifting t minus 1 whole square u of t minus 1 divided by 2. That is inverse Laplace transform of this one. So t minus 1 whole square u of t minus 1 by 2 means the option B right. Some more questions. GATE 2013 question, right? The impulse response of a system is h of t equal to t u of t. For an input, u of t minus 1, the output is options are given like this. These are the options. The h of t given, input given, output asked. So all are in time domain. Better you go to the Laplace transform. S domain, come back. So first h of s how much? H of s is 1 by s square. And input is u of t minus 1. That means x of s is 1 by s e to the power of minus s. Then output y of s is x of s, x of s. That is 1 by s square e to the power of minus s 1 by s, or 1 by s cube e to the power of minus s. Just now we have done 1 by s cube inverse Laplace transform is t square u of t by 2. Here one side multiplication of the exponential by minus s. Obviously other side same shifting. So t minus 1 whole square by 2 u of t minus 1 is the inverse Laplace transform of the given function. So this should be the output y of t. So right option is C. Okay. Good. One more question. GATE 2011 question. Right? Let the Laplace transform of the function f of t, a function f of t which exists for t greater than or equal to 0 is f1 of s and Laplace transform of its delayed version f of t minus t naught be f2 of s. Let f1 complex conjugate of s be the complex conjugate of f1 of s if g of s is f2 of s, f1 complex conjugate of s divided by f1 of s whole square. Then inverse Laplace transform of g of s is. Questions look like very difficult, but I'm telling you it is very easy. Options are given like this. I think all of you got answer by this time. Observe this. He says that f1 of s is Laplace transform of f of t. F1 of s. And f2 of s is what? Laplace transform of delayed version f of t minus tau. Then what is f2 of s? f1 of s into e power minus s over delayed time domain exponential multiplication in the s domain. Then f1 complex conjugate is as given like this. G of s expression consider. f2 of s is f1 of s e to the power of minus s tau and f1 complex conjugate of s divided by magnitude of f1 of s whole square. Now for a complex function, x into x complex conjugate is nothing but mod x square. So f1 of s, f complex conjugate of s and square of magnitude all will cancel. So what we will remember remaining means e power minus s tau remain. If del of t Laplace transform 1, then e power minus s tau Laplace transform is what? S domain exponential multiplication, time domain shifting by same amount. So this is the answer. Del of t minus tau. Ideal delayed impulse function with the shifting. Is it? Question looks like complex, but logic is very simple to solve. Right. That is about the Laplace transform. We can solve different problems. The Laplace transform not at all troubling the students. That's why I have not spent much time on Laplace transform. Already jet transform, all possible variations I have done for you. So with that knowledge, you can easily follow the Laplace transforms. That's why I not spend much on Laplace transform. A number of exercises you can do, but logics, complete logics which are required to solve those problems I have discussed here. Now you can take any book, you can try to solve any problem, you can do it easily. But jet transform I have not neglected, it is clearly covered each and every point. That's sufficient. Students generally feel jet transform difficult than Laplace transform. That's why I focus much on jet transform than Laplace transform. However, in mathematics also you should have been solved many problems on Laplace transform. This is sufficient for you for Laplace transform, I think. I hope all the best to all of you for your GATE examination. I think the time is 6 o'clock. Our schedule is 3 to 6, right? Fine. Thanks for your support. Anu, CJ, Leo, Thomas. All the best to all of you. Write the GATE exam very well. Get settled well in your life. From the bottom of my heart, I am wishing you. Thank you.